All right, so today we're going to take notes on vertical kinematics. We just finished our unit on horizontal kinematics. We're going to use the same formulas as we used in horizontal kinematics, except we're changing our plane from the x-plane to the y only. So things that go up and down is all we care about in this unit. All right, so let's start with a little bit about what we're doing. So we're doing things that are in free fall at this point. So what does free fall mean? That means an object is only acted on by gravity. Okay, so that means that the motion is just up and down. We assume that there is no air resistance. And now, instead of us calculating our A in all of our equations that are acceleration becomes G. On Earth, G, which is gravity, the gravity constant, is negative 9.81 meters per second squared. Okay, that is always what gravity is on Earth. The reason that it's negative is because the force of gravity is always pulling down. So it is a vector quantity, just like acceleration was before. But just so you remember, if something is going down, it has a negative sign connotation. If something is traveling up, it has a positive sign convention. So acceleration due to gravity is always going down, so it will always have a negative. Even if you throw a ball up, the sign will still be negative on the gravity, because when you throw something up, it slows down, which means negative acceleration in the positive direction. If something is falling down, it's going faster and faster, which means if you're going in a negative direction, which is down, and your acceleration is also down, so it's negative, if your acceleration and your velocity have the exact same sign, they are speeding up. If they have opposite signs, they are slowing down. All right, so let's do an example problem. We'll jump right in. Okay, so I have two examples for you today. First example problem. Okay, you have a ball is dropped from a window and is caught 3.5 meters below. I want to know, A, how fast is it moving when caught? And that means like the moment it hits the glove, not after it hits the glove, okay? After it hits the glove, obviously it's not moving, it's zero, okay? Don't be a smarty pants. It's how fast is it moving the moment that it's caught, okay? And then part B, I want to know how long does this take? Okay, so sometimes it's helpful to draw a picture. Okay, so if we're going to draw a picture, let's see. So I've got, here's my tower, and here's the ground below or wherever it's being caught, okay? And so I have a ball that's being dropped down, and it's going to hit the ground or hit the glove of whoever's catching it, right? The tower itself is 3.5 meters tall, so from here to here is 3.5 meters, okay? If it's being dropped, then I know that my initial velocity is 0 meters per second. So because this has acceleration in it, it's a VIVF-AST problem. So we're going to write those down, VIVF-AST. Now, I'm looking for VF because it says how fast is it moving when it's caught. So I know that I'm looking for that. My A is now going to be replaced by G, which is negative 9.81. So that's negative 9.81 meters per second squared. It's on your formula sheet, but you may as well memorize it. My S, because this ball is falling down 3.5 meters, S is displacement, which is a vector quantity. If it's moving down, it should have a negative sign in front of it. So this is negative 3.5 meters. And then I don't know how long it falls. That's the second part of my problem that I need to find. So I need to find an equation that encompasses the things that I have so that I can find the things that I don't have. So if you look at your equation sheet,